Hello everybody, my name is Clayton Davis and I'm here with Sawmill Dave, and today what we're going to do is we're going to talk to you a little bit about Chassis, which is an open source project with the rather ambitious goal of helping you to run your AI anywhere. A little agenda item for you. I'll talk to you about what Chassis is, where it came from, kind of where it fits in the MLOps pipeline, and our overall sort of long-term goals before transitioning you over to Sawmill, who'll run you through a demo of actually using Chassis, and then we'll finish up with a few resource links for those of you who are interested in learning a little bit more. So a quick note about what Chassis is, where it came from. Sawmill and I, in our day jobs, we help companies transition AI that they've created from their laboratory environments into their production environments. And what we've learned over the last few years is that companies have spent a lot of money in building up their data science departments, and they've spent a lot of money in building up their DevOps groups and teams. And what that means is that they haven't really spent a lot of time in that in-between area, right? And so when data science teams build models that are meant to influence the company in some way, shape, form, or fashion, what they usually output is just a small little file, right? And what DevOps teams need in order to make those AI models available to the rest of the enterprise and end users is actually a container. And so what Sawmill and I do is we help people to make the transition from I have a model that does the thing that I care about to I have a container that can make that model available to the enterprise. And after doing this with lots of clients and for ourselves several times over and over, what we identified were several pain points along the way that consistently came up when we were trying to transition models from the laboratory out into production environments. And by getting together and identifying those sort of consistent pain points, we were also able to identify ways that we commonly went around those pain points or just avoided them altogether. And once we had that list together of sort of those codified lessons learned, we took those lessons and we donated them back into the community in the form of something we called the Open Model Initiative. Now, for those of you who are interested in kind of the lessons learned themselves, you can go check out openmodel.ml, and it'll show you those lessons that we found to be most beneficial to know about when you were trying to transition models from the laboratory into production. But once we had posted that information back and kind of donated it back to the community, we decided it wasn't enough to simply have those lessons learned available to help guide the people who would come after us, that what we really needed to do instead was to go ahead and create an automated way to help people transition their models from the laboratory into production environments. And that was really the genesis of Chassis. And so Chassis as a project or as a program, right, sits in your MLOps pipeline right in the middle between your data science team and your DevOps team. It takes in as input a model that's been developed by the data science team, and as output produces a container that your DevOps team can then automatically use to distribute your AI model either across the enterprise in the cloud or directly to an IoT device, or even sitting just simply on your desktop for your own personal use. Okay. Long-term, our goal with Chassis is to provide a simple mechanism to allow all AI models developed in labs to be easily distributed anywhere. And when we say simple, we mean that we want people to be able to take advantage of Chassis using just a simple, just a few lines of Python code. We don't want anyone to ever have to go out and learn a whole new sort of DevOps discipline in order to be able to leverage their own models. And so when we say simple, we mean just that. Few lines of code, no new knowledge required. When we say anywhere, what we mean is that we want Chassis to be able to generate containers that can run on any sort of device that would commonly be considered useful for an AI model to run, be that CPUs, GPUs, ARM processors, Intel, cloud, IoT, or desktop. And so with that background in mind, I'm going to transition over to Sawmill, who's going to show us a demo of Chassis running.
Chassis builds models into DevOps-ready container images. Under the hood, it uses two key tools, MLflow and Canico. MLflow provides a really nice PyFunc generalizable model interface that we leverage. It also is able to infer the dependencies required to run your model. So those are the two pieces of functionality we use there. Canico is an open source tool that allows you to build model images within Kubernetes without access to Docker. We've abstracted away the usage of both of those tools, so the user doesn't actually need to directly interact with either of them. Chassis generates open model interface compatible images, which Clayton mentioned earlier. If you're interested, please visit openmodel.ml. It is a proposed spec for a multi-platform model image. So if you'd like to learn more about that, please visit the site. And these model images will be able to run locally. So you can just download the proto file and start hitting the different routes and running inference. They can also run on Kserve and Modzy. So real quick, sort of an architecture diagram here. Chassis consists of two pieces. There is the Python SDK with which the user interacts, and there is the chassis service, which is deployed to a Kubernetes cluster. So using the SDK, you will package up your model into the required format, and I'll show you an example of that in a second. You will submit a build job to the chassis service, which will then spawn Canico build jobs and go ahead and containerize your image, as I previously explained. So in order to deploy chassis, pretty easy to get started. Let's say you want to run on a local Minikube cluster. Install a few dependencies, Helm repo add chassis, update, Helm install chassis, make sure it's up and running, and we'll port forward the service so that we can hit it just like this. So pretty easy to get started. And here's how it actually works. Here's a general outline. So you'll pip install your chassis SDK. You will use whatever your framework of choice is. Chassis supports most frameworks. And you'll go ahead and load your model and anything else required into memory that needs to persist across inference runs. Then you'll define this process function, which takes bytes as input, and it's required. You're required to implement everything required to go from those bytes all the way through formatted inference results. So pre-processing, running inference, and then post-processing needs to be done here. If you want to split these into separate functions, you can do so as well, as long as you call them from here. Then you'll initialize using the chassis SDK, your chassis client, and pointing to a running chassis service instance. And then we'll create our model passing that process function that we defined above, and we'll call publish, which will kick off the image build. And just real quick, the SDK is pretty well documented on the site here, so please feel free to check that out. So to an actual example, I've got my notebook here. First thing we're going to do, import our chassis SDK along with some other model-specific things, Torch Vision, NumPy, OpenCV. Here, you're required to enter Docker Hub credentials. Chassis is going to push this image to your Docker Hub. And optionally, you can deploy all the way through to Modzy. If you want to do so, you can provide your API key here. I've already done so. So here, we're going to load in our model. We're going to use a PyTorch pre-trained ResNet 50 model, pre-trained on ImageNet. And we'll also load human readable labels so we can map the output class indices to human readable labels, our torch transform, and our device. Again, anything that needs to be loaded once and persist across inference calls. We'll then define our process function. So just like in the outline, pre-processing inference and then formatting out the results and returning that. We will then initialize our chassis client, pointing to our running instance of chassis, the service that is. We will provide our process function that we defined above to this create model method of our chassis client. And we will point to an image that I've got sitting locally of an airplane, and we will test the model locally to make sure everything is working as expected. And as you can see by these inference results, it looks like they are. That is, everything is working. And you can also test the environment. So if you call this test end functionality, that will hit another route in the service that will actually go ahead and spin up your entire environment and test the model within that environment to make sure that your dependencies are sufficient. We're not going to do that right now because that takes a few minutes. So you'll notice that we haven't done anything with dependencies. The really nice thing, as I mentioned earlier, because we use MLflow under the hood, if you don't specify a Conda environment, it will automatically infer the required dependencies for you and save that out along with the model that gets submitted to the chassis service. You can also optionally specify your Conda environment if you'd like to, though. All right, so here we're ready to actually kick off a chassis job. So the only 4 required arguments are these top 4. You're going to need to provide a model name, a version, and the Docker Hub credentials we defined earlier in the notebook. Optionally, you can deploy all the way through to an instance of Modzy by providing a sample input file path, the API key we defined earlier, and point to a running instance of chassis. So we'll go ahead and kick this off. So what's happening right now is the model is being saved out in the MLflow PyFunc format. All the dependencies are being inferred as well. And in a second here, once we see OK, that'll mean that the job has kicked off on the chassis side. So let's go ahead and, yep, there it is. All right, so I've already spun up the chassis service and done the port forwarding. So let's just make sure that the job has started. Here's our chassis service pod, and here is our newly formed chassis, the pod that's running the job that we just submitted. So we'll go ahead and take a look at the logs to make sure that's executing correctly. Sorry about that. As you can see, the build has started. Now this is going to take several minutes, so I'm going to go ahead and kill it for now, and we'll use an image resulting from a previous chassis job just for demo purposes. All right, so I've got an image that resulted from a previous chassis job. I basically just did a Docker pull, and I spun up the container locally with this command, making sure to map out the port so that we can access it via localhost. So we'll go over to Postman, which is software that helps you build or test APIs. It's got some gRPC functionality, which we're going to leverage. So I've downloaded this proto file. This is the open model interface proto file. I've imported it into Postman. We're pointing to a localhost 45,000. And what we can do is go ahead and hit the status route, which is going to give us a bunch of information about the model, the name, the version, author, input, output formats, that sort of thing. And we can go ahead and submit a job. So as you can see, I've structured the payload as follows. This is a base 64 encoded image of a dog that I've got sitting on my desktop. And we'll go ahead and call that route. And as you can see, looks like Inference successfully executed against that model image that was built by Chassis. This is base 64. So we're going to need to go back to the browser, and we'll use this tool that allows us to decode the base 64 into our results. And as you can see, there's a few different dog breeds that the model thinks that this image is. All right, so I just showed the model image, the container running locally. As I mentioned earlier, if you deploy all the way through to Modzy, you can submit a job to Modzy with the Modzy SDK as follows. You can also deploy to Kserve, and there's some more information on the site here if you're interested. But basically, you need to specify certain fields in your YAML. We'll specify the interface as Kserve, and then we'll just run a kube control apply. So Chassis also supports other functionality that we didn't show in that first example. For example, batch inference and GPU support. So for batch inference, we basically accept a list of inputs rather than the single input, and we're responsible for providing back a list of outputs. We then specify our batch process function when we create our model, specify a batch size, and we can put GPU equals true here in our publish call, and then Chassis knows that it needs to use a GPU compatible base image. We can also specify ARM64 here, and so we can build images that can be deployed to things like Jetson Nano and Raspberry Pi without needing to have an ARM64 instance in your cluster. And last thing I want to show, in our repo, which Clayton is about to give you the link to, if you go to the SDK directory and then to examples, there are a wealth of examples with different frameworks and different model types so that you can really get a sense of the way that this thing works. And with that, I'm going to hand it back over to Clayton. Thanks for your time.
All right, thanks a lot, Sawmill. Anyone who's interested in learning more about Chassis, feel free to visit our resource links at openmodel.ml or chassis.ml. And if you're interested in getting involved or actually seeing the other examples available that Sawmill was just talking about, feel free to stop by our GitHub page. Thanks a lot for your time.